Good afternoon, everyone. Today I'll be doing a video on mathematical induction, and I'll be doing it for the CAPE level. So this is for pure math. I know it's in other subjects like discrete math, stuff like that, but I'm only covering it for CAPE. I'm pretty sure the concept stays the same, so as long as you understand the concept, you should be fine. Now, before we even start mathematical induction, the first things we need to really understand are the rules. So the rules state that show that n equals 1 is true. That is the first rule. We're trying to show that n equals 1 is true. The second rule is to show, it's to assume. Now we're trying to assume that n equals k is true. So when doing these two rules at least, they're complete if you marks. You're just substituting in the values. Where we see n equal 1, or we see n equal k for the second rule, and that's essentially just it. And then for the third rule is assume. Okay, so here's the catch. So sometimes, depending on the subject, it says assume. I'm personally in class, I'm learning assume. In some textbooks I see show, so I'm not really sure which one to put, but since assume is the one I'm learning, that's just what I would say. Assume n equals k plus 1 is true. Now these probably don't mean anything to you if you're not actually trying an example, so I'm going to try to work an example right now. Alright, so for normally the typical question goes like prove by the principle of mathematical induction that so and so is whatever, for all natural numbers of whatever. So essentially they're going to give you something like a summation like this: n r equals 1 r 3r minus 1 is equal n squared n plus 1. Right, and this is just a symbol. This isn't really like a part. This is not a part of the question, right? First of all, before we get into this, I'd just like to say, if you haven't already completed like summations, you don't know, you look at this formula like and you have no idea what's going on, I'd recommend that you go back one topic in the textbook or any textbook and just look up like the foundation topics for mathematical induction, because if you don't understand what's going on here, then it's probably going to be very difficult because you won't have the foundation topics. So if you don't know that already, I'd advise you to teach it, but this video is really just mathematical induction because I don't want to have a 40-minute video teaching everything, right? So let's continue. So we have this is equal to n squared times n plus 1, and so the first step, you don't actually have to put the 1 here, but I'm just putting it there for clarity. Show n equals 1 is true. So let's look at it first for a second. Wherever we see n, we're just going to plug in 1. But before we even get to this part, what I would personally recommend is, for example, for a situation like this where we have r outside the bracket on this side, we could really just FOIL. And by FOIL, I mean take it and multiply it by both things in here in the bracket. I think it's just a good idea so that you can be very clear, but we'll go to that in a second. But the main important thing is to find where the n is, and n is right here. N is also around this whole formula, so there's no n's anywhere else, so we'll just substitute 1 for those n's. So I have the summation 1 r equals 1 r 3r minus 1 equals, the first formula was n squared n plus 1, so we'll have it equals to 1 squared times 1 plus 1. So this is the left hand side. You'll see LHS on as LHS, you have to write on the left hand side, and this is the right hand side. If n equals 1 is true, then both of these will be equal to the same figure. So since this is 1 to 1, we'll now have r equals 1. We'll plug r equals 1 into this equation. But before that, we'll FOIL it. So r times 3r is equal to 3r squared, and r times negative 1 is equal to minus r. Right? And so now we'll have 3 times 1 squared minus 1. 3 times 1 squared is the same as 3 times 1 times 1, and 3 times 1 is 3. 3 minus 1 is 2. So on the left hand side we have it's equal to 2, and on the right hand side it's equal to 1 times 1. This dot right here, it's not a point, it's called a dot product. If you aren't aware of that, I'm not actually putting a point or anything, it's just a dot product, right? Which is just me multiplying. So it's another way for using a multiplication symbol. So 1 times 1 times 2 is equal to 1 times 2. And with that we can see that it's equal to 2. So your concluding statement for the first rule will be, since the left hand side is equal to the right hand side, n equals 1 is true. Nice. Very free step. Like, this should be very easy marks for you on the paper if we ever get something this simple. But yeah, this is just simple substitution. Really, really simple. If you don't understand something at this level, please go back and check the foundation. But yeah. Next, the second rule is assume n equals k is true. Right, so we're assuming that n equals k is true. So wherever we see n, we'll now put k. We'll go back up just to show more. So we'll have n here, and we'll have the same n over here. Right, so we'll just switch k for those. It's as simple as that. And because we followed previous up here with the 3r squared minus r, right there, we want to just put that back instead of having the r outside the brackets. So we'll have 3r squared minus r, where r is equal to 1, and since n should be here, we'll put k, because wherever we see n, we'll put k instead. I will have that equating to, I'll put the first formula here so we can just see what we're going to be substituting, n squared, n plus 1. So wherever we see n, we put k, so that's k squared times k plus 1. And that's the entire second step. Should be getting those marks, should not be an issue. Third step now. This is where things get a little bit more tricky. Not for the actual third step, but just for what comes after. So next we're going to assume, well, this is another thing. In my textbook it says show, but in class I've been learning that it should be assume. I'm not really sure which one's right. I'm not like a professional mathematician, but I don't really see the difference and the problem if you use either word. But just in case, for cape, this is what I've been seeing. I've been seeing assume, so I'll be using assume for this. So assume n equals k plus 1 is true. And what I was talking about is that this assume, sometimes I see it as show, but I'm not sure which one is like really right. So again, wherever we see n, we put k plus 1. There is an n here, so we'll put k plus 1 here. And this is a 3r squared minus r equals 1. Equals, and we can see the formula up here, n squared, n plus 1. Wherever we see n squared, so we'll have k plus 1 squared times k plus 1, because that's where n is, right here. And then we'll have that plus 1. Please don't forget to add this additional 1, because sometimes it happens, and that is just very, very wrong. So next, we'll be simplified a little bit more. Not too much, please don't simplify too much. And we'll have k plus 2. What I did originally was I'd foil everything and make it into one single equation without having to multiply anything, but my teacher said that was wrong, and actually just, not wrong, but he took marks off. So I'd recommend not doing that, because they're not testing it to see if you're able to do that. They're testing to see if you'll be able to factor it back out, because that's actually the hard part. Because, yeah. So now we see here, this right here is the very important part of this whole, oh my, what's going on? My tablet is like dying. My drawing tablet is. This step is very important. This is actually what we're trying to work towards. So, how on earth are we supposed to get this? The main goal of mathematical induction is to equate to this exact, like, k plus 1 squared times k plus 2. We're trying to get back to that. And the way we do that is we'll add the kth term no, not the k term, we'll add the k plus 1th term, as well as the formula for where n is equal to k. Essentially, we're saying that n is equal to k plus 1. We're saying that this should be equal to the summation of k. Well, I don't know if that's what it's called, summation of k. I'm not sure if that's wrong or right. Plus the k plus 1th term. Right? That's essentially what we're saying. I'll explain to you what k plus 1th term means soon, so just don't worry about it for now. For now, we'll just worry about this right here. This should look familiar, right? Because we actually already worked this out. So if you go back up, doing step 2 alone, if you did it correctly, you should be well on your way to getting the question correct. So since this is the exact same thing, we'll just use this format instead. So k squared, k plus 1. K squared times k plus 1. And then what we're trying to do, since that was this term right here, we're trying to add it to the k plus 1th term. But what is that? The k plus 1th term in the sequence is when you take k plus 1, this right here, and plug it right here. If you plug the k plus 1 in here, you'll get the k plus 1th term. So we'll have 3, where we see these r's right here for the k plus 1th term, we'll have k plus 1 squared minus k plus 1. Right? Okay. So this is partially where a lot of students get what you say, did get, what do you call it, did get lost. Yeah, so try not to get very lost here. Remember, we're trying to go back and solve for this right here, this equation. Not, well, yeah, this is what we're trying to solve for. That's the whole purpose. We're trying to get back what n equals k plus 1 is, right? So we'll have k squared, k plus 1, and then we also have, we can just to make it a little bit easier, plus 3 k plus 1 squared minus k plus 1. And now to just kind of expand it a little bit, we can factor out k plus 1 here in this term, right? Because there are 2 k plus 1s. So because there are 2, we can factor them both. As you see here, k plus 1 squared and minus k plus 1. So we can have k squared, k plus 1, and that is plus what is common to both of these, k plus 1, so we can factor it out. If you don't know how to factor, I'd recommend that you go back over some more foundation topics. And then now that we remove the k plus 1, what do we have here? What times k plus 1 gives you 3k plus 1? We'll have to multiply 3, so normally we'd have 3. So take out the k plus 1 out of the brackets, and we isolate it, right? Not really isolate, we don't isolate it, we just take it out. So we'll have that, and then we'll have to multiply it by 3, k plus 1, because in order to get back the 3k plus 1 squared, 3 times k plus 1 squared, and then in order to get back k plus 1 on this side right here, this is a k, we'll just have to have minus 1. That's all. It's just factoring. If you don't understand factoring as much, again, I recommend you go over some videos, previous videos from some other channel. I don't have any of those up right now, but in the future I will probably, right? So next we have k squared, k plus 1, and now is when we're going to start like folding again, just a little bit more. So by folding, I mean we're going to expand the brackets. So this will be equal to 3k plus 3 minus 1, which is the same thing as 3k plus 2. So k squared, k plus 1 plus another k plus 1 times 3k plus 2. Right, I'm sorry it looks a little bit messy. Trying to keep it a little bit neater, but yeah. Now, what do you notice here? We have k plus 1 twice, right? So in the same way, we can factor out another k plus 1. When we factor something out, we pull it out of the equation, right? We pull it out so that we can work everything back to get this. So we'll have k plus 1 outside of the bracket, and inside the brackets we'll have to get k squared times k plus 1. So in order to multiply it by that, we'll just have k squared first, just in order. So k plus 1 times k squared is equal to this same equation right here, just factoring, right? What next? Next we're going to have, since we already pulled out the k plus 1, this will not even be there, right? We'll have this next. So we'll just literally add 3k plus 2, because we factor out the k plus 1. We'll get back the same thing, which is good. Now again, this is a very simple part. What we do is we'll use the AC method in quadratics. So as you can realize, this is a quadratic because it takes the form y equals ax squared plus bx plus c. Oops. Plus c. So because of that, it is a quadratic, and we can use the AC method to factor it. Right? So we'll have so in order to do the AC method, we'll have to multiply a times c and try to get back b. So 1 times 2 is 3, and 2 plus 1 is 3. So the things we'll be using are a equals 1 and c equals 2. 1 times 2 is 3, and 1 plus 2 is 3. 1 times 2 is 2, sorry. Oh my gosh, I'm so sorry. 1 times 2 is 2, and 2 plus 1 is 3. Right? I've been saying that wrong for a while. Please, I'm very sorry. So now we'll have k plus 1, and because we'll be breaking this up, this won't be k squared plus 3k plus 2 anymore. We'll have k plus 1, k plus 2. Right? Things should be simple. So k plus 1, this k plus 1 that was already outside the brackets, and then we'll just have it in a bracket because we're still multiplying, and we're going to multiply it by wait, k squared. Yeah, by k plus 1 times k plus 2. Yeah, sorry, I got a little lost in my own calculations for a second there. And so what is this the same as saying? Right? This is the same as saying k plus 1 times k plus 1. K plus 1 times k plus 1 is the same as saying k plus 1 squared. So k plus 1 squared times k plus 2. And if you notice, this is the exact same thing as we found up here. This is the thing that we're trying to work for over here. We're trying to work for this equation, and we're able to get it successfully. Again, try not to factor it out too much because you might lose marks because they're not really marking for that. I'm not sure how that works, but yeah. And just to remind you, I'm not sure about if it's the same for discrete math, but for CAPE math at least, I know that you should have your concluding statements. So now we'll have, since n equals 1 is true, and n equals k implies, oh, what's going on? Oh no. N equals it implies n equals k plus 1. Then, and what we're essentially saying is that because those two are true, this whole equation is true. So in your concluding statement, just write back this entire equation right here, just as you got it from the question itself, and that should be how it works. So then the summation where n r equals 1, you can keep the factored form, so 3r squared minus r is equal to n squared times n plus 1. And I don't know if you'll lose marks if you forget this thing. Sorry, I did it wrong. Right? And that's really it. Mathematical induction is not that hard. There will be more difficult questions, obviously. There'll be some with like some really hard questions, especially for unit 2. But yeah, I forgot to specify this video is actually catering to unit 1. My apologies if that was not made clear from the beginning. But yeah, this was made for Unit 1 because that's the unit I'm currently doing. And yeah, if you found any errors with this video, like I made a mistake or something, please comment it below because I'm still learning the topic myself. And this is just as best as I'm able to understand it. So with that said, I think that's pretty much all for this video. I was thinking of doing another example, but it's kind of tedious to do, and I'm not sure if a long drawn out video is best for this. So yeah, this is also my first video on this channel doing math videos. I'll be intending to do more math content on this video as I go through the pure math syllabus. So if you're interested in that, you can subscribe. If not, you can just look up CAPE videos whenever you want and you don't have to subscribe. It's really fine. But with that said, thank you very much for watching, and goodbye.